Okay, Algebra 2, yesterday we started this section 6.5, operations on radicals. It was a lot. So we did example 1 and 2, and 3, I guess, and there was A's and B's and all that good stuff. We are only going to do example 4, and then I am not going to have you do example 5 or 6. So we're going to do example 4, but before we do that, I'm going to go back and I'm going to just go through your homework assignment, and let's do number 3 and number 11. So you can just write this down on your homework assignment, but I want to do one more extra problem from each before we get into example 4. So these two problems, these blue ones right here, we're going to do, and then I'll show you example 4, and then we will be done. But the homework assignment, I'll have you do the rest of these. I told you to do 2, 4, 6 yesterday. If you have not done those, example 3 might help to see before you do those. Otherwise, these are the rest that you're going to do for Monday, I guess. So let's do number 3 and 11, and then we'll go back to example 4, and we'll see how this goes, okay? So let me make this a little bit cleaner here. We have, this is a square root, okay? Down here we were doing this, number 5 is a fourth root. This one is not a fourth root or a cubic root. This is a square root. If there's no number there, we assume it's a 2, okay? So square root, and we have 4 pieces underneath. So 24, this guy, this guy, this guy, okay? So what I'm going to do is I'm going to break those into 4 pieces. So I have the square root of 24. I've got the square root of a to the 16th power. I've got the square root of b to the 8th power, and I've got the square root of c, okay? So all of those are broken apart. Now, I don't know if you like to do the ones that come out nicely first, but like when you're doing a square root and you're dealing with these 3, you are taking that exponent and you're dividing it by 2. If you were doing a fourth root, you would be dividing it by 4. If you're doing a cubic root, you're dividing it by 3. So I'm just taking this exponent and I'm dividing it by 2. And because 16 does divide by 2 nicely, this just becomes a to the, this becomes a to the 8th power, right? 16 divided by 2 is 8, okay? Now, if you don't believe that that's how that works, I have a lot of people that look at 16 and they're like, no, that should be a to the 4th power, right? Because the square root of 16 is 4. When you're doing exponents, you're dividing by 2. You're not taking the square root of the exponent, okay? Because a square root says what 2 numbers or what 2 things do I multiply by itself, to get a to the 16th power. A to the 8th times itself will give me 16, okay? The a to the 4th will not get me, if I take a to the 4th times a to the 4th, that is a to the 8th power. That is not a to the 16th power. So exponents, when you're doing exponents, you want to divide by 2, or if it's a cubic root, you divide by 3, that type of thing, okay? Now, this one right here is the same way because 8 is an even number. By taking the square root of b to the 8th power, I'm just dividing 8 by 2, so that would be b to the 4th power. Now again, if you want to check, that means b to the 4th times b to the 4th gives me b to the 8th. That is true, right? So those come out nicely, all right? C, the square root of c, this is like to the 1st power. Now, the deal here is c to the 1st power is already less than 2. So I can't even do anything to that one. He just stays the square root of c, and I'm going to leave him like that. I'm going to circle all of these when I know I'm done, okay? Now, I'm going to go up here. Don't write this down. If this was like, let's say, the square root of c to the 7th power, let's say instead, right? 7 is my exponent. If I try to divide him by 2, 7 doesn't divide by 2, right? 7 divided by 2 is 3.5, okay? Keep that in the back of your mind for just a second. So when I'm taking the square root of c to the 7th power, I want to put 6 of them over here and 1 of them over here because that makes a total of 7, right? So if I take the square root of c to the 6th power, that's c to the 3rd. I'm just dividing by 2. But then the square root of c by itself just stays like that, right? Okay, so I said before, this is a way that you can kind of check your answer. I said before that 7 divided by 2, because that's my root, it was 3.5. 3.5, okay? The 3 comes out, but the half means he just stays inside of the square root, right? Because a square root means c to the 1/2 power. That's what a square root does, okay? So that's kind of one way that you can check yourself is that, you know, the exponent divided by 2 was 3.5, so 3.5 here, okay? All right, but that wasn't what the problem was. The problem was just c, so we have just the square root of c. Now, 24, we just do like normal. You cannot take the square root of 24, so I'm going to break him down, and I'm thinking, like, what number goes into 24 that I can take the square root of? We're doing square roots. So, like, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, right? I'm looking for these numbers that would go into 24. And I think the only thing that works is 4 and 6, okay? The square root of 4 comes out to be 2, and the square root of 6 doesn't come out, so I just leave him underneath, and that's what 24 will look like. So I'm going to circle him. And then the last thing that I do is I take all of this stuff, and I lump it all back together, okay? And when I do that, I take the outsides, so 2 is on the outside, a to the 8th power is on the outside, b to the 4th power is on the outside, and then this is on the inside, and that's on the inside. So 6c, the square root of 6c is left underneath, and that's what he will look like when he is simplified, okay? So that was kind of a long explanation. I did do some extra stuff up there, but that's just another example of how this all works when you're breaking stuff down, okay? Let's go and do like number 11. We did one like this yesterday that was a little bit confusing, but we want to add these square roots together. So I have 3 pieces that I'm adding together, this one, this one, this one, and we can only add them together if they're the same. Kind of like if I try to take like x squared plus x cubed. I can't add them together if they're not the same like exponent, right? Okay, I can take x squared times x cubed, right? Like I can multiply them together, but I can't add them together, okay? So what I have to do is I have to make sure that they're all broken down. The square root of 2, he's already a small number. He cannot be changed. He is going to stay the square root of 2, okay? But let's see if 8 will break down. So the square root of 8, I want a number that goes into 8 that I can take the square root of, and I'm thinking like 4 and 2, right? So if I take the square root of 4, that becomes 2, and the square root of 2, he's going to stay. 2, so 8 becomes 2 square roots of 2. 2 square roots of 2, okay? Now I'm going to do the same thing to 50, and let me go over here. The square root of 50, okay? I want a number that goes into 50 that I can take the square root of, and I'm thinking like 25 and 2, right? Okay, the square root of 25 is 5, and the square root of 2, he's going to stay underneath because he won't break down. So 50 is 5 square roots of 2, okay? Now I can put some stuff together because I have the square root of 2, I have 2 square roots of 2, and I have 5 square roots of 2, okay? So the number that's out in front of this square root of 2 is 1. It's kind of like having an x. 1 is the number in front of an x, right? Okay, so I have 1 square root of 2 plus 2 square roots of 2 plus 5 square roots of 2, okay? 1 plus 2 plus 5 is like 8, okay? And you don't add the 2's together, it's just going to be 8 square roots of 2 is what he will look like, okay? So that was maybe a little bit cleaner and a little bit better of an example than what they had for like example 3 or whatever it was. But that's how you will add those together. You try to get them all to be the same base. And if this would have been 5 square roots of 3, we would have just added these 2 together and not this one. Does that make sense? So, you know, they have to all 3 be the same base in order to add them together, and they did come out to be the same base. So 8 square roots of 2, okay? So hopefully that can help you do number 12 and number 14, okay? On number 14, there is a 2 out in front here, right? So let me help you do this one real quick. 2 square roots of 48. If I'm trying to break that down, 2 square roots of 48. I'm just going to focus on the 48 right now. 48. I know that 4 goes into 48. Don't write that down. 4 goes into 48 12 times, but bigger than 12 or bigger than 4 is 16. 16 goes into 48 3 times. So I want to use the biggest number if I can to break stuff down, okay? So now I have 16 and 3, and I have those square roots. The square root of 16 became 4, and the square root of 3 stays the square root of 3, okay? Now, the problem is the square root of 48 is 4 square roots of 3, but what do I do with this 2 right here? Like the 2 is still out there in front, okay? You're going to take these 2 and you're going to multiply them together. So this is going to become 8 square roots of 3, okay? So breaking down 48, you do it just like normal, but if there's a number in front, then you have to multiply it by your number that you have on the outside. Okay, you'll have to do that for, well, maybe that's it, because 2 square root of 3 here is the only other one that has a number on the outside, but the square root of 3 is not going to break down, so he's just 2 square root of 3. So just be careful with that. If you ever see that again, you break him down, you have to multiply those numbers out in front. Okay, so continue to break these guys down, and you can add them together if they're the same base. Okay, all right, let's go down and do example 4. Again, we're skipping example 7, example 6, example 5. We're going to example 4, multiplying radicals. Okay, so these are both fifth roots, and I have 2 pieces. I've got this piece, and I'm multiplying by this piece. Okay, so the way that this works is I only have 2 numbers that are on the outside, 4 and 3. And those 2 numbers I'm going to multiply together. I'm going to do this over here. Okay, so putting that stuff up there at the top. 4 times 3 are the 2 numbers that I have on the outside, and that's going to become 12. 4 times 3 is 12. And then I have the fifth root of all of the other junk. Okay. All right, so I want to, when I do the stuff underneath, I want to multiply this number by this number. So the 10 and the 16, negative 10 and 16 can go together. Negative 10 times 16 is negative 160. Negative 160, okay? Then I want to put the x's together and the y's together. So I have x squared and x to the 4th, okay? And when you have them like that, you are going to add the exponents, okay? So if it's like x squared and x to the 4th power, that becomes x to the 6th power. That's when I'm adding exponents. Here's what it has to look like in order for me to multiply exponents. Why is that doing that? This is when I would multiply the exponents, okay? So that would be x to the 8th power, all right? So just keep those separated in your mind of when you add and when you multiply. Here you're adding. So x squared and x to the 4th becomes x to the 6th power underneath, okay? X to the 6th power, okay? Then we have y to the 6th and y to the 4th, and again, you're adding the exponents, so that becomes y to the 10th power, okay? And now all we have to do is break stuff down. Like the 3 pieces that I have underneath of here, I'm going to try to break those down, okay? So this is the last part. This 12 is just going to chill. He's just going to hang on, and that's going to be in my final answer, okay? But I need to look at the 5th root of negative 160. Can I have a negative underneath of there? If you have an odd power or an odd root, you can, right? It's not an imaginary number unless it's an even number, because I can take 5 numbers and multiply them together, and then I would come out with a negative number, right? 5 negatives make a negative. 5 negatives don't make a positive, okay? Then I have the 5th root of x to the 6th power, and I have the 5th root of y to the 10th power, okay? Let's work on the 5th root of y to the 10th power again first, because he comes out nice. Again, when you're doing exponents, 10 is your exponent. We're just dividing by the root. So 10 divided by 5 is 2. So this is y to the 2nd power. He comes out nice. We have nothing left underneath. He is good to go, okay? Let's work backwards with this guy. So this one is not going to come out nice. 6 divided by 5 does not come out nice, okay? But what he does, what we want to do is we want to break him into pieces. So I can take the 5th root of x to the 5th power, right? But then that would mean I would have to hang 1 off here in order for this total to be 6, okay? Then I take my 5th root. So the 5th root of this guy and the 5th root of this guy. The 5th root of x to the 5th power is just x, so he's going to come out, right? And then I'm going to have the 5th root of x underneath, because this doesn't come out nicely, so I just leave him underneath, okay? So one of them is going to come out, but then one's going to be left underneath, okay? I hope that makes sense. All right. This one, negative 160, I have to figure out, what number can I use that I can take the perfect 5th root of? Like, I know it has to be negative. So negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is going to be negative 1, right? Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. There's 5 of those. That is negative 32. And I wonder if 32 goes into 60. I don't know. My brain, it's Friday. My brain's not working. Let's see. 160 divided by 32 is 5. Yeah, so that would work if I put negative 32 here and 5 here. Sometimes you have to do some dabbling off to the side, and that's okay. So I have 32 and 5, and I want to take the fifth root. Okay, so the fifth root and the fifth root. The fifth root of negative 32 is negative 2. I take negative 2 times itself 5 times to get negative 32. So that comes out, and then I have that fifth root of 5 left over. Okay, so this is the answer to that one. This is the answer to that one. This is the answer to that one. But don't forget that you have 12 left over. He's just chilling. We got to put them all back together. Okay, so now I'm going to have my fifth root. I'm going to put what I have on the outside, what I have on the inside, and then we're good to go, okay? All right, so on the outside, I have 12 and negative 2, and I have to multiply those together. So that's going to be negative 24. So I'm going to cross them off as I go. Also on the outside, I have an x, and also on the outside, I have a y squared. So I've got x, y squared, there he is. The rest of it that I have underneath is the fifth root of 5, and x is also underneath. So this is my final answer. I didn't need to make this bar that long. Whatever, it's fine. So there's that. It's kind of ugly, but that's how that works, okay? So the whole purpose of what we were doing in example 4 was multiplying. So you just multiply by combining stuff together, and then you reduce it at the very end. Did they give us an answer? Oh, no, they got negative 24xy squared. So they got that, but they don't have this filled in. That should be 5x down here. Okay, so yeah, multiply the stuff that you can and then just reduce it. Fifth roots and fourth roots and third roots are kind of hard because you're not used to seeing them. Square roots are maybe a little bit better, but just try to keep your head on straight and remember what a fifth root means. You take it times itself 5 times. Again, cross off those examples, but here is the homework problems again. So try to get your way through 12 through 28, those guys, and then do 2, 4, 6 if you haven't already done those. But hopefully that gives you a little bit better of an idea. Eventually, maybe next week sometime, we will get to doing some whiteboards, okay? And we'll just rapid fire some of these and see if we can get them to work out, okay? All right, so try to do the best you can. If you need to work together, go for it, okay? Oh, shoot. We didn't talk about 26 and 28. No, we didn't. We didn't do those. Okay, let's see. What are we going to do? Let's have you... Let's have you wait on 26 and 28. I don't want to make this video any longer. So let's wait on 26, 28. You can cancel those off. So just do the other 4 for homework if you haven't already done the top 3. Or if you have done the top 3, okay? So you can cross off 26, 28. We'll save those for Monday, okay? All right, there you go.